Objective 3. Compute the probability of an event using the complement rule. Now suppose the probability of an event E is known, and we would like to determine the probability that E does not occur. This can be accomplished using the idea of complements. If we let S denote the sample space of a probability experiment and let the event E denote the event, the complement of E is denoted by E with an exponent of C. It is all the outcomes in the sample space S that are not outcomes in the event E. Because E and the complement of E are mutually exclusive, we would say that the probability of event E or the complement of E would equal the probability of event E plus the probability of the complement, which would equal the probability of the sample space, which is equal to 1. Now, subtracting the probability of E from both sides, we would obtain the following, which is the complement rule. If event E represents any event and the complement of E represents the complement, then we would say the probability of the complement of E is equal to 1 minus the probability of event E. So here, this is the entire region, and the area of the region outside of the circle represents the complement because the inside represents the event E. So let's take a look at an example, illustrating the complement rule. According to the American Veterinary Medical Association, 31.6% of American households own a dog. What is the probability that a randomly selected household does not own a dog? So what we need to do is we need to find out what is the probability of no dog. Well, it's going to equal 1 minus the probability of a dog. Well, what is the probability of a dog in our example? Well, we can see that it represents 31.6%, and if we convert that to a decimal, it'd be 0.316. So therefore, we're going to say that the probability of having a dog is 0.316. So to find the complement of having probability of no dog is taking 1 and subtracting 0.316, which gives us 0.684. So the probability of randomly selecting an American who does not own a dog is 0.684. Let's take a look at another example, computing probabilities using complements. Now the data in the table below represent the travel time to work for residents of Hartford County, Connecticut. So here's the travel time, less than 5 minutes, 5 to 9 minutes, all the way to 90 or more minutes. We have the frequency for each particular driving time. And then we have the relative frequency. How do we find the relative frequency? Well, we take each frequency and divide it by the total. So remember that if the total is 393,186, then we're going to take each frequency and divide that by the total frequency to get the relative frequency of 0.062. So this is another way of saying probability. The probability that the travel time is less than 5 minutes is somewhere around 0.062 or 6.2%. Likewise, the probability of travel time to be 5 to 9 minutes would be 0.099 or 9.9%. Now, we're going to answer the following questions. It says, what is the probability that a randomly selected resident has a travel time of 90 or more minutes? So what we want to do is we want to determine the probability of finding the relative frequency of the event 90 or more minutes. So when we look at the event 90 or more minutes, we know that the frequency is 4,895. And so when we look at the relative frequency, when we divide it by the total of frequency, then we're going to get the probability of 0.012. And if you look here, to find the probability of 90 or more minutes, we take the value of the frequency of 4,895 and then divide it by the total frequency of 3,000 393,186 to get the probability of 0.012. Now, if we randomly selected 1,000 residents of Hartford County, Connecticut, we would expect about 12 of the residents to have a travel time of 90 or more minutes. A travel time of 90 or more minutes is unusual. Okay, so let's take a look at those two items that we just discussed. Well, first of all, if we want to convert this into a fraction, that means that the value of the 2 ends in the thousands place. So therefore, this represents 12 over 1,000. Okay, now also, how do we know that the travel time of 90 or more minutes is unusual? Remember that it is unusual if it is less than the 5%. So the probability of 0.012 is less than 0.05, which makes this unusual. Okay, now in part B it says, what is the probability that a randomly selected resident of Hartford County, Connecticut will have a travel time less than 90 minutes? Now, although this probability can be computed using the addition rule for disjoint events, it is more efficient to use the complement rule because the complement of less than 90 minutes is 90 or more minutes. So that means we can either add up all these probabilities or we can just take this probability and subtract it from 1. So if E represents any event and then the complement represents that complement, then we would say that the probability of the complement is equal to 1 minus the probability of that event. So what we're looking for is the probability that it is less than 90 minutes. Okay? The probability that is less than 90 minutes is taking 1 and subtracting the complement of less than 90 minutes, which would be the probability of 90 minutes or more. Okay, so we're going to take this 1 and then subtract the probability that we got for 90 minutes or more. Well, we saw that in our example here. We saw that we got 0.012. So if we take 1 and subtract 0.012, we would get the probability of 0.988. Okay, now let's convert that to a fraction. That means that this becomes 988 over 1,000. So we would say that if we randomly selected 1,000 residents of Hartford County, Connecticut, we would expect about 988 of the residents to have a travel time less than 90 minutes.